Off we go to gas laws. So I will admit that these can be very interesting and to lead to some nice demonstrations. So you will get to see some things that are hands-on. And so that's good. In essence.
So no.
Yeah. All right, the first thing we need to talk about are all the different variables you might see in one of the formulas. N is the variable that we use for mole. It is the amount of gas. N, little n, is the amount of gas in moles. Make sure you write that down. The amount of gas in moles. Because the mole is the SI unit for how we count. Now that's not new information, but it's a variable. Its symbol, little n, probably has not been reviewed or looked at since the very, very beginning of the year. So that would make things, that would make it hard for you to remember. But again, that's not new information. Pretend to write, at least. No, listening is good. We want to all take the time and listen. But we also want to have the note in our notebook. You do understand the role of the notebook, don't you?
Study.
It's simply just to add another book to our book.
Well, it is actually is a step in having you to harness to create a bridge between my brain and your brains. And this notebook is the middle of that bridge. Right now it's my learning. And your job is to make it your learning. So that's why I ask you to review your notes every night. If you review your notes every night, two things happen. Thing one, you start to possess the learning. The stuff actually does go into your brain. Now, not everyone's a good visual or whatever. Some people should rewrite them. Some people make flashcards. Some people do things like that. That's fine. You can do those things if you actually are spending time with your notes. I don't know how you learn. And some of you I do know how you learn because we've spent enough time together. But I do know that if you spend zero time with it, then the learning is not yours. It's still mine. And you need to make it yours. So that is step one. So make sure you've taken that note down neatly. You can read it. And then how you best start to take possession of that knowledge, that's what you need to do on a nightly basis. That is the point of the notebook. I'm hoping. Now, there are other variables that you're going to need. This is not new, and it's not really that difficult. The big T, little n stands for mole, big T stands for?
Taylor.
Temperature.
Mr. Peace.
Now,
He's still here.
most of us already know this conceptually. Like, you actually enjoy the concept, experience the concept, and sometimes you maybe have pondered the concept. For instance, it has been nice temperature-wise over the past about week and a half.
I fear we jinxed
Now,
it.
it has now gotten pretty cold out. So some of you may have gotten outside and done some of your spring things. I don't know, maybe taking a soccer ball out or something like that.
40-foot cliff.
What happens though, if you were on your way to your car this morning and you kicked your soccer ball that was left outside?
You break your toe.
Probably not.
The ball would just shatter
The
into
ball
a
is
million
cold.
pieces.
The ball was
The ball cold.
It would just
Okay,
shatter into
ball,
a million pieces.
one of the outcomes could be a frozen ball, but
I'm on to something.
Icy.
that's probably
It's wet.
Yeah, then it just shatters.
It's probably deflated.
Probably. Okay, Jeremiah, I like that. Why would the soccer ball be deflated?
Because the air
Our
pressure.
dog got changes pressure.
Something shatters.
It's cold.
Yeah, gases, and again, this is just something you guys have run into. Jeremiah is correct.
Good job,
The
Jeremiah.
gases in the soccer ball today if you had left it outside, would have seemed, it would have seemed so that the gases would have escaped, and all of a sudden your ball is flat. That is not what has taken place. We're going to find out that gases greatly react to the temperature of your system. And one of the ways they react is they actually take up less space. Now, who can remember, and of course, temperature can have different, what are the main two temperature scales we mess with in this class?
Kelvin and Celsius.
Yeah, we mess
Kelvin.
with Kelvin and Celsius.
Why don't we do
So-
degrees like normal Americans?
All of our temperatures are going to be in Kelvin or Celsius in this class. We very, very rarely talk about Fahrenheit at all. Well, one, the rest of the world who does science also uses Celsius.
I thought only America existed.
Yeah.
It's not only America, but there's only like a handful that do. Everyone else does use Celsius.
My friend,
I thought America's the only country that existed.
she said, and because she's in chemistry right now, she
And
said
Japan.
the hardest thing is actually getting Celsius to Fahrenheit because it's like a stupid.
Yeah, 9/5, 32. Those are the, or 5/9.
Why doesn't the
minus
world just
32.
be like America and then like do
Look,
our
we're-
stuff?
Believe it or not, for people who have actually traveled or by now lived in other countries, America has a massive influence on the rest of the world, believe it or not.
Jamaica.
It's almost like we're a world superpower.
It is almost like that.
It's almost like all pop culture just pumps here.
No,
We're a joke with nuclear weapons.
no one looks at us as a joke.
Oh, now we're getting political. Cut the tape. Cut the
Occasionally
tape.
look it up.
We don't look as us. We are.
Now we're getting political. Cut the tape.
No, I don't think so.
No, we're America.
What?
Shout out Joe Biden.
Please sponsor us.
Let's not
This is not
go down these roads.
Political.
Pressure.
No, we'll fall off.
Definitely not YouTube kids anymore.
No. Pressure's the other
Right, the
unit.
video.
The SI unit for pressure is the Pascal. And so you can imagine that if we're gonna be dealing with pressures, we're gonna have to know this unit equality again.
Yes, sir.
Again, all of this is not new. It may seem new to some of you, but you have taken all of these notes before.
Yeah, I remember studying this.
Yeah.
We did.
Oh my god.
So,
Great
as you
Shadow
can see
Legends,
here, we
please
do have the
sponsor us.
formula that you are to remember.
Oh, we don't have
And of course, the one quick way to know if you've got the right formula, if you ever have a negative Kelvin temperature, you know you're using the wrong formula because Kelvin is an absolute temperature scale and cannot go below 0 because Kelvin's 0 point is absolute 0, which is a theoretical 0 point. We believe it exists.
We like the 0
Science
point.
says it exists.
Great Shadow Legends, please sponsor.
We've gotten really close to what we believe is absolute 0, but again, it's still theoretical. And then last but not least, we see this pressure unit equality here. So, yes, as promised from the very first lecture on, you do need to know this stuff throughout the year because these are some of the tools you'll be using throughout the year. And so again, here we're dipping in our toe yet again into some of that knowledge. Now, anytime a gas comes in contact with a surface, it exerts a force, and this force is called pressure. So if we wanted to really put a kind of some words to what pressure is a force per unit of area. And you can experience pressure pretty easily by just taking 2 of your fingers and pressing on your forehead.
That's it.
That's pressure.
Whoa.
Why not one finger?
One finger can do it
Is
too.
PSI like
Pounds
same?
per square
Oh, it's
inch.
Pounds per square inch.
Yep.
My bad. Never mind.
Now, we don't use PSI in science class a lot. We stick with ATMs and pascals and millimeters of mercury, but a PSI is very much used in automotive and other type of things. In fact, most tire pressures are done in PSI.
That's a different. That would be like, wouldn't that? That's weight over area instead of. You said it would be force over volume. Force per.
Pounds per square inch.
You were saying when you were defining pressure, you were like it's force per like amount.
Yeah,
That's how
Well-
many pounds of pressure
per square inch, and that you'll okay when we get into physics, and some of you will, you're gonna find out that when we get to really what Newton's mass and forces are. I can't tell you how intertwined they are. Let's just put it that way. So the reason we kind of know masses exist is because they exert forces. So rather than get into a huge lengthy explanation of that, I do like how, yeah, so it's a mass per square inch, but it'll end up being in newtons, it'll end up being a force. But again, that's not 100% different science. They obviously overlap. But the explanations you'll learn next year in physics. Many of you will take physics if you're not.
No.
Physics or computer science.
I don't
Take your chemistry.
You learn like coding, how to use Word and stuff.
Wait,
How to open
I
Google
think I'm
Docs.
taking chemistry.
Certain
How?
level of knowledge.
Some of you might. We might have a second crack at chem.
I have to. This school I go
Not
to.
me.
And the last one is volume.
Some of us don't have a choice.
The SI unit is the meter cubed, which is a very odd unit.
You play.
I will admit, of all the SI units, I don't know why meter cubed is the SI unit. It is a massive amount of volume. So in most cases, we'll be using the liter or milliliter for sure. That is a much more usable volume, even though it is not the SI unit. But you never know, I might ask for SI units.
SIE.
Acai units. Now I want an acai bowl.
So let's have a, Shh, you can't see.
I see now.
Do you need to go to the nurse?
No, I can see.
Why did we have that?
I don't know.
That was
He says it
perfect
all the
not to
time,
play.
I say that all the time. Emma has vision problems in chemistry.
It's all those chemicals being in our eyes.
Alright,
Raid Shadow Legends, please sponsor us.
again, not new material, but notice something here about gases. It takes a lot of variables to kind of describe them. Like when we talk about solid things, many times what do we really use to describe a solid? Like,
Mass and volume.
yeah, we kind of use its mass often. We just throw it on a scale, and we might use some physical characteristics. Ah, this is shiny, and this is not shiny. It looks like a rock or anything like that. So, again, gases, though, because of their weird nature, it takes a lot of different variables to kind of really describe what a gas is actually doing at a certain particular time. So, we do find some interesting things about them, though. Let's not forget what atmospheric pressure is, because I've had some people, like, we have numerous questions that says at ATM, or sorry, at STP, and everyone's like, what's STP? Standard temperature and pressure has been in your notes probably 5 times now.
Also at our airport.
So, atmospheric pressure is the pressure exerted by the air in the atmosphere. We'll take a couple, like I said, gases are very fun. We'll take a couple peek at these things. Most of you, maybe we'll crush another can. Most of you have seen that before.
Should bring
Is
another
that the
guy.
same thing as
Just go to a
barometric
NASCAR
pressure?
day.
We can definitely,
think
I
I want
wanna get a vacuum pump for
crazy.
Compass Academy for
It's
sure.
pretty crazy.
Vacuum pumps
Hey, you're
rock.
not part of the discussion.
What can you do with those, like, vacuum?
You could just create an environment without air, and when you do that,
I mean, just like.
weird things
experiment-
happen.
Experiment wise, like, what can you do with that?
It's more demonstrations than an experiment, but you can carry out experiments
So
without the pressure.
It just crushes things.
just try to melt
Maybe
the
boils water.
We should do like an oil drum.
No, there's a lot of good things. You can boil water at room temperature, that's cool, yes. You can do some real torture to marshmallow heaps and stuff like that.
Not the marshmallows.
The exploding marshmallow.
So,
Can I eat them after?
yes,
Can I have a bathroom?
probably, yes.
Can I go after? May I go after?
I guess.
Okay, thank you.
Those are really
Go,
good.
can you be trusted to like go at the same time?
Animals.
Is that
Animals
just a
too.
kind of a policy that we do? One at a
I was
time?
talking about
Well,
animals.
I mean, that's
like
what
lizard,
Chemistry,
monkeys.
right here, I don't think
I
it
need to
makes
ask
much of a difference.
I would just, as long as you think you're a trustworthy person.
Behave yourself.
What is that supposed to
If
do?
you're so
What is that supposed to
Julia
mean?
wanted it.
Oliver, what do you mean, what is that supposed to mean?
What, like, what?
How do you
Why should
define
you be trustworthy to go to the
trustworthy?
bathroom?
How do any of us?
Because Julia
I don't
define
know.
trustworthy?
Why do people send them one at a time?
And what's different when?
I don't know.
Okay, so obviously there's some kind of issue there. So I was just trying to hammer that out. Because I honestly would rather them get back to class quickly than constant people going in and out. Why are we
Like a
having this discussion?
revolving
I have no
door.
idea.
Yes, Jack?
Why is he doing what I do?
This might be a dumb question, but like,
Wait, we have this on film,
how do you
right?
measure
Yeah.
the pressure
Yeah,
of
let's-
like, well,
What?
so STP,
Standard temperature pressure.
yeah,
This is definitely not
but
YouTube.
water is solid.
I'm just gonna dewater that.
At 0?
Yeah,
Afraid we need you.
so that's free.
NordVPN.
Yeah. So,
For the record, this channel is homophobic and we do not support that.
well, water's not the only thing. In fact, water makes up a very small part of our atmosphere.
Yeah.
We need Raid Shadow right
So,
now.
but water vapor, we can find out, certainly, we know the temperatures in the atmosphere, in the troposphere where weather actually takes place, is pretty cold.
Okay.
In fact, we know it condenses into clouds, so we know it can form a liquid. Now those clouds, those water droplets are really small. We're talking 1,000,000 times smaller than a normal rain droplet. But we also know they can condense, get heavy, and
What's that?
precipitate. So, yeah, we're, again, at normal conditions, I agree with you, Jack. Water would be turning to ice. It's actually right at equilibrium. Water is ice and water.
What?
You heard
Well, at
it here.
0 degrees Celsius, both ice and water can exist.
Yeah.
It would be depending on, they're actually in equilibrium.
Like my ice pack.
So as water is turning to ice, ice is turning into water at that time.
I still think the ball would
There's no wet
shatter.
ice or freezing toward the water.
I still think the soccer ball would shatter.
We will talk about equilibriums, both physical and chemical. Chemical we'll focus on the most, but we'll talk about equilibriums here in another chapter or so.
What's an
So-
equilibrium?
Yes,
Is barometric and atmospheric pressure the same or no?
they kind of measure the same thing. A meteorologist would tell you no, but
Wait, so George Flickinger?
barometric pressure is
What
just
time?
taking the atmospheric pressure and using.
Shout out George Flickinger.
Tool.
Nice.
All right, kinetic molecular theory. These are just tenets.
He's such a flake.
Some of us know this. Shh. Again, it will get fun to see these things. This is the learning part. We'll go ahead and we'll do some of these demonstrations to really demonstrate this. You'll do some of them. You'll have your hands on some of this stuff too. I do wish we had some of the tools. We're starting to build up an inventory. And so it's just gonna take a few years. We are further along than we were last year in chemistry, which is good. Each year we'll get a little bit more stuff. Most
Gas
people
has
realize that gas has mass.
Bars.
So
That is-
some people don't though. But whenever you feel a very hard gust of wind, that's evidence. That gas has mass. You're being hit by the air.
It hurts.
And air you can start to feel, it exerts a force on you and you're like, hey, it's windy out.
I never thought of it that way.
It is
But
very windy
that's
out
what's
today.
happening.
You feel the mass.
I feel the mass.
But the fire is so delightful.
Now we are gonna get some of the more weird stuff happening with gases. This one's not weird. The kinetic molecular theory, okay, gas has mass. If I didn't realize that, okay, now I do. I can feel that.
But what if I wish that I never knew that?
Sorry.
Plastic.
A single gas molecule's volume is unimportant. Huh? Well, that doesn't make any sense.
Say it.
Again, remember what a theory is. Who can define a theory for me very quick?
Plausible guess.
It is not like a law.
Sorry.
It's okay. That is the exact opposite, kind of. Yes.
It's a
Common belief.
educated guess.
Common
It's
belief
take
like a
Basque.
belief in
is,
something.
is getting closer.
It's not belief.
It's an opinion.
It's
It's
not.
like what
It's
you
Everyone's
not
a-
a belief or
It's like
opinion.
Democrat.
It's
Everyone.
a conviction.
How about
It's
this?
like you believe it, but
It's a religion.
No.
It's like it's not fully tested.
Everyone's allowed to voice their opinions.
It's a religion.
There is no false. Yeah.
It's a cult.
Whatever the heck.
It's almost exactly different from that.
It's almost exactly. You just gave up your
It
hope.
is
No
close
way, I just
though.
felt unimportant.
It is.
It's a cult.
It is our best guess based on the latest
Diabetes.
Yeah.
experiments.
It's heretical.
Really.
It's not.
Why down? It is our best guess based on. It is our best. It's actually an explanation. It is our best explanation based on the latest data or latest experiments.
It's that.
Now, will theories change? They obviously change. We went through the atomic theory. It changed numerous times over like 50 years. So we know that theories will change as more experimentation results into more explanations that are better than the previous explanations. But I will say this, the kinetic molecular theory of gases, even though we know that that is not true, that we're not really, that a gas molecule, we know that one gas molecule certainly takes up a volume. But here's the problem, or I guess you could say the issue with gas molecules. We don't realize this because we can't really see them. I can't just show them to you. We can create these, and we will look at some of those online kind of models to show these gas molecules moving. But gas molecules moving with so much energy that instead of being at one space at one time, they actually just fill up the space of whatever container they're in. In other words, yes, that single gas molecule, if there was one, let's say this was airtight, if there was one gas molecule in here, you would say that the volume of that gas molecule is the entire cup. Why would you say the volume of that gas
It's
molecule is the
moving
entire
so
cup?
fast it fills the entire space.
It would be all over the place all the time.
First, they preach it.
And I know that
Give me another 50
seems,
one right there.
You could.
but here's what happens. You ready?
You just promote
The
their
math
Compass Cam
works.
to get 25%.
Oh, there's definitely, with that moving that fast, hitting the surfaces, friction takes place, yes,
Code
heat
Compass
is being
Cam to get
generated.
25%.
In fact, this is all the idea of absolute zero. We take things that can be cooled down, like nitrogen, make it liquid nitrogen, then we make it solid nitrogen. We're trying to take energy off of it, stop it from moving by taking heat away. So that's where thermochemistry actually comes into this, and that's trying to get us to absolute zero. And absolute zero is the place where all atomic motion stops. And if the atomic motion stops, technically you would have, it actually points to a volume of zero. Well, how can you have
What?
something with no volume?
That's
Kinda
impossible.
crazy.
That's impossible.
Of course, and that's why absolute zero right now is just a point on a graph. It's theoretical. Everything points to, oh, within millions and millions of degrees.
Can you go back a slide?
Back a slide.
Why are we going back to sleep?
I mean, that's a war. Wow. I'm surprised in many ways.
You surprised I hope it's not
Expectation is
No,
no.
no, no. Not-
Holy cow, is that a
I don't
crayon?
have it.
She took my marker away.
This is like your fifth page of your notebook.
How old are you?
What? You're looking at me like I'm not healthy.
Well,
I'd like to thank NordVPN for sponsoring this
You
video.
have to-
use
you have to
use
lower
code Compass
your-
Kid to get 25% off.
You have to lower people's expectations of you so that when you take one note, they're impressed. That's the secret.
Alright, 3, the third postulate. Gas particles are always on the move. Again, I like to have a visual. If you've ever ridden on bumper cars at the amusement park of any kind,
Oh,
I
it's
like
so
that a
much
lot.
fun.
Even that person that tries to go hide in the corner, oh, they're gonna be moving. Why?
People gonna bump them.
People are gonna
Bump
hit
'em.
'em.
It's more of a target.
It's definitely, if you're not going fast, you're going to get moved.
Yeah, TA
So-
first, your last.
So, this idea of things just bouncing off of each other all the time,
Those are so fun. Oh.
they are fun.
They're
They can
awesome.
also
They go
cause
bum bum.
health issues.
I had like a little kid with one. It's so
This video
funny.
is sponsored by Whiplash.
Yeah, he went flying.
Yeah.
That seems like it could be like a win.
I like ran over a child.
No, why was yours so quick?
I was going really fast in this
But that
school
picture-
zone, and like
Little subatomic bouncing balls or bumper cars bouncing off of each other. That is what was going on in these containers. Gases. We know that everything's always on the move. I mean, even in a solid, you gotta have movement, but not like a gas. Gases are flying around. And here's another one. We know that's not, because of what Preston said earlier, we know that this is not
Started something.
100% true, but we're going to assume that all of these collisions are perfectly elastic. If you've ever had a really good bouncy ball,
oh
like a really good one,
oh yeah.
Those are the best.
you bounce it off a hard surface and it literally almost comes all the way back up to your hand,
Yep.
exactly where you dropped it.
It's fun to hit against the walls and like goes everywhere. So cool.
Bow, bow.
Those good, like really good bouncy balls, are what we want to picture in our brain. As hard as you throw it at the wall is how hard it comes back at you. Now, Preston did say earlier, as something hits a surface, it's going to create heat or friction. So we know that this is not true. But the math works, again. If the math works, and right now this is our best explanation.
Math is just made up by humans.
That one is greatly debated right there.
It was discovered and maybe
Math is
written
real.
out by humans. Oh my god. But
English.
Most
is fake.
mathematicians, I would say nearly, almost 100%, we're talking 99.99,
That's math.
believe math is discovered.
Geometry is real.
Yeah, but triangle.
Geometry is not real.
It's not real.
There's I use it
Alright.
in the real world.
Any words here you do not
No, it's real.
understand. Well, we define pressure.
That's just made
You gotta
up.
prove it.
Of course, when it hits a surface, it's going to
DIY
exert
projects are
pressure,
made up.
a force.
Oh, okay.
Everything's made up. The whole world is a lie.
All right, so all these things are bouncing around, everything's moving. We got a real kind of, the volume is whatever the container is. Like, we've got some really interesting things happening with gases in just these 4 statements. Now there's more.
No.
And that's not all.
And that's not all.
This one I do believe you got in your brain because of our previous discussion. The energy is directly proportional to the temperature. Yes.
Can I go to the bathroom still?
You may quickly.
Go back.
I know I did the math right.
This is out.
But math's made up.
Directly proportional.
Of course, I used the words directly proportional. What does that mean for kind of?
Straight ahead.
I can't say no, but they're not exactly equal. Yes,
It just means like when you increase one, the other increases.
yes, the directionality of the change is the same. If one increases, the other will also increase. And
What?
depending on a lot of these can be linear relationships.
Nika.
They can increase at a particular rate. They don't have to be, but Many of them are, when they're directly or inversely proportional, just the difference in the direction of that graph. Energy of gas particles is directly proportional to the temperature. You heat them up, what happens to the energy? And if you increase the energy, you've increased the temperature. And this is what happens in your, notice the explanation of Jeremiah's for instance. Jeremiah said, if I go kick my soccer ball this morning, it would be, or appear to be, deflated. Well, as the temperature went down, the energy of those gas particles went down. As those go down, the number of collisions go down. As the number of collisions go down, the pressure on the surfaces does what?
Goes down.
It goes down.
What does chemistry
This
think about
actually
free
makes
will and
sense.
predestination?
Just by the fact
Well,
that
now
And
we're
his
really gonna.
assumption-
30 seconds, go.
This is an assumption for sure. No intermolecular forces are in action. No intermolecular forces are at play here. Oh, I like it. So we need to define what an intermolecular force is, and I think it will make some sense. So let's do a little definition here. Good question. So what is an intermolecular force? So get the note and start using our brain. No intermolecular forces are in action.
I'm convinced this is made up. This has to be made up. But...
In a way, this is a theory,
Oh.
but it is an explanation based on data.
I think
Like this
we were
works. We're
predestined
gonna find
to
out
get
it
this
works.
note directly from you.
Hmm.
We are going to find out it
Maybe we had the
works.
free will to write it.
Let's focus.
Is that an error?
I think I was predestined to get an A in this class.
Yeah. But then
And you have the free will to do that.
You have the free will to do nothing.
Yeah.
Got 30 seconds to explain predestination versus free will.
Well, I got about 30 seconds to actually ask what an intermolecular force is.
We were predestined not to answer.
It's inside a molecular
Intermolecular
force.
forces are
Boom.
Bennett had an answer.
Wait, Bennett did.
Yeah, but Rhett was talking.
Molecular. Yes, we've got a guess.
Does it mean that molecules in different gases don't like interact with each other?
Molecules of different gases can interact with each other. I like it. So in other words, intermolecular meaning
inside.
one molecule versus another molecule. And so we're going to find out the identity of the other gas wouldn't even matter. Okay? These things are just bouncing around. So what we're saying is that these molecules will get close to each other and they will not interact in any way. They'll just boom, perfectly elastic collisions. So intermolecular forces are forces between two different molecules.
What?
Wait.
Wait, I was kind of right.
What time is it?
4 minutes. 4 minutes?
Time flies when you're having fun.
Oh, yeah.
Yeah.
Yup.
Wait, I was actually kind of right.
Yeah, you were.
No, you weren't.
Eileen said
Bradley,
molecules.
you were wrong.
No, Eileen said molecules inside of another.
All right, look, these are
What does that say?
forces
Molecules.
between
Molecules.
two different molecules.
I was actually.
Side conversations
That's
do not lead to understanding.
I can't read it.
You're both. The teachers have molecules.
Teachers have what?
I think the teachers should have, like how seniors, you normally have senior quiz. I think teachers should just have quiz this year.
Okay.
Word to your mother.
Terrible.
Where's your mother? For any of y'all who have speds inside angle side.
Oh, that's me.
Both sides.
Forces between two different molecules.
That's me.
That or you're being an angle. She said that in our class.
Yeah,
That's so.
Now,
Not funny anymore. Not funny anymore.
quiet down.
still need that shirt.
These, don't miss the teaching part. Just because you have the note down doesn't mean we start side conversations. Yes, as Jack just said, they're assuming these don't take place. Don't put it away yet. And we do know that when molecules get next to each other, they do exert forces on each other. For instance, if in a cloud, the reason clouds, we see them, is because water molecules go through this thing called polar bonding, which is an intermolecular force. They stick to each other. It has called cohesion. And that's why clouds gather in the sky, because water molecules do stick together.
What?
So that leads us now, with those explanations, to our gas laws. Now this is a different thing. We have a kinetic molecular theory, but now we're talking about gas laws.
Do I need a different page for this?
No. Just make sure it's titled. This is why the difference between what a theory and a law is. So the theory we just explained is our best explanation for what we're about to observe, because remember what a gas law or a law of nature is. A law of nature is a generally observed behavior that encompasses many systems. It means it happens. This is what we're going to observe. No, you don't need that note for now, because that note should already be in your brain. I guess we're packing up.
Yep.
I guess so.
Well, since you guys are now
Oh no.
describing when we're gonna have tests, now I guess you guys describe when class ends.
No, it's just.
We'll do the class.
I like how the power structure in the class has changed.
Yep.
Very nice.
Oh,
Cut.
What a video.
Okay, put it down.